Alright, so let's start from where we last left our project. So we have a chessboard, right? And we are able to put any pieces on it. I don't really like that it's on the same colors. Maybe I can do something like a bit different colors, but we'll see about that. And something else that I would like to do, usually when it comes to ds.h, and when a project grows a bit more, like I need to use more files or stuff like that, I like to create a ds.c file, and in this ds.c file I like to put all my defines and also include ds.h. So the purpose of this file is to be basically, because ds.h contains both the definition and the header, usually you want to split those two things, and these defines are, actually responsible for generating the C part of the implementation. So if I put them in a ds.c file, should be easier to work with. And now we have to not forget to, at this point we can just include ds.h, right? And it shouldn't complain about anything, I'd say, I guess. Let's just see. It's obviously gonna complain because we want to link to also include the ds.c file now at this point. Right. But now, yeah, it complains that stdlib is not found because we compile without stdlib. And interesting, maybe we need to be able to put no std everywhere, but here is another problem. It requires either. Maybe we don't want to have this as an error here. Maybe that shouldn't be an error, actually. And maybe even this warning shouldn't be a warning. Oops. Maybe maybe this is fine, like this, without any warnings. So I guess it makes sense you have to add this ds-no stdlib in all your files that are generating WASM. Maybe that makes sense. I don't think, well, kind of needs access to ds.h. Okay, anyways. So yeah, but I usually like to have this as a separate file, which I think makes sense. Anyway, so for today I was thinking to be able to have all the pieces, like place them how they usually look like, and be able to move them. But yeah, first let's try to switch up the colors for these things. And maybe, so bishop dark, let's try to use bishop light. Let's see if white is fine as a color, because I'm not sure. Well, white it's fine, it works, but the black it's kind of ugly, black on black. So let's maybe change this to something else, like blue, or maybe not something completely dark, but something like this, like a dark gray. Wait. Oh, this should be it, but it's still kind of not enough, I would say. It's better, but it's still, maybe we can use a different color, but let's keep it as it is for now. Let's keep it gray. Okay, perfect. So we have this function that is able to print a board, right? It just prints all the rectangles, and we should, But I mean, this is just printing the base. So we can have a function maybe that is something like print. I guess print board makes sense. So without anything. And then we should have print pieces, I guess. Okay, whatever. So print board. Because here we have fill piece, but we don't really need fill piece to be called every time. We need to check what we have in the board, a row and column. So maybe something like if board but row column is not empty, we want to fill piece with the thing from row column. So at this point it should be empty because we don't have any pieces, but we can try to have some kind of function. So instead of chess.h, I have these functions that I want to implement. One of them is reset board, which just sets the pieces in order. We have this chess print board, which we just implemented kind of. Okay, I can rename it to chess print board. Okay, we have chess moves, which I think it should give us all the moves that are possible for a piece. So we give it, a square, a start square, and it should give us all the end squares that can be reached. Then we have print move, which it's supposed to give us like a display of for a move. Like for instance, if you click on a piece, it should show you a circle where the piece can move. So that's, start and end, whatever. And we have apply move, which should update the board with the given move. Okay, so that's my idea. And we have this main.c file, which I would honestly maybe rename it into, like, it's the WASM version for this implementation, right? That's what it's basically about, because this header file, it's like, okay, so that's how the chess engine should work. It should have a reset function, a print board, get all the moves that are possible for a piece, be able to print a move, like, okay, you want to you move the pawn from somewhere to somewhere, and updating the board. I think these are the functions that we need. We'll see if we need to change them or need different functions, but yeah. And this main.c file is the WASM stuff. And this wasm.h file, these are the functions that we need from JavaScript. Okay. So yeah, maybe we can rename this main file to something like chess_wasm. Maybe. And in here, we'll call this thing chess_wasm. Right. Okay. So we have print chess print board. Okay, perfect. All right. We should have a reset board implementation. So reset board, it's going to set all the pieces as they should be on the board. So let's just say, it's going to be board at 0, 0. This is the top. Interesting. If I think about it, 0, 0 should be... Here it depends on how do you want to look at it, because 0, 0 is gonna be top left. But maybe we wanted 0, 0 to be the bottom left, right? Just so we are consistent with the notations like A, B, C and 1, 2, 3 or whatever. Maybe, yeah, maybe we want to switch things up a little bit like that. Let me see. So that would mean that I guess the column stays the same, but for the rows we want to have it a bit different. So for the row we want to start from the bottom. So maybe it's chess height minus row, right, times height. And maybe we need a -1 as well. I don't think so. Actually I think we need a -1, because if you think about it, if the row is 0, then we want chess height -1. Okay, if we rerun this thing, it's the other way around now, so we need to also switch up the colors. So here is the other way around actually. Right, and now we have the board as it is, but we start from the bottom left, which I think is the right way to do it. Okay, now I mean this function could be better. Maybe we wanted to have something like a static int to get the color, and maybe we want to call it something like chess square color or something, and we give it a row and column, and it's something like this. Right, so this gives us the color of a chess square. Chess square color, row and column. Well, I mean, you know, in chess they are called, I think, what they are called. I mean, I call them row and columns. I don't really care, but I think they are called differently. Maybe it's like a file for the columns and something else for the row, but I don't know, because I don't really care. I want just to have an AI that can beat, you know, noobs at chess. I mean, if it can beat me, then I'm happy with the result, honestly. Okay, so we have the color perfect. We are able to print the pieces. So let's implement the reset function for real now this time. So at position 0, 0, we should have a rook light. What do you mean about that? So this thing is a number, but board, the fuck? Wait a second. I think I need to dereference board. Okay, so if we run this thing, we should see now. Oh, I forgot to call chess board. Wait, what? Chess reset board. Okay, perfect. And we give it the address of the board. Nice. So we should see our rook right here. Now, the thing that's kind of ugly, it's the pieces look ugly, honestly. That's because the pieces, I think they are 60 by 60 and the squares are 100 by 100. Maybe we can fix that in our TypeScript file. Maybe there is a way to draw image with some kind of is there some kind of context draw image? Is there some kind of resizing that we can use? Doesn't look like we have resizing, so it's gonna be ugly. It is what it is. I mean, what I can change though is this stuff. Like I can make it what, 60 times 8, 60 times 8, and this should, I didn't have to compile it, right? Well, what? If I hard refresh, it doesn't work. It looks the same, so let's keep it 800 by 800. Anyway, so that should be the rook. I don't think we can make it easier, honestly. So board at 0, 7, it should be the other rook. It's annoying that I have to, oh, it's actually, so this is actually the, wait, let me double check. So here I said it's width, and that's the height. So what the fuck is wrong with the board? So row goes from 0 to height, and columns is like that. Okay, so column, yeah, that's fine. So this should be the column. So then why does it look like that? Maybe because X, maybe because here it's Y. Shit, I think it's Y and X probably. Right, but it's not right. Huh. So it's 0, 7. Hmm. Yeah, it's something's wrong. Let's just think about it. So we have, basically I wanted the second index to be the column, right? That's why I used width here and here height. And we have something like this. We have an, so 0, 7. We iterate the rows, the columns, then we say something like X is going to be, so this should be, maybe I can call it C for column and R for row. So the column is going to be column times width. That's the column in pixels. Let's call it maybe column underscore pixels and row underscore pixels. So it's going to be column times width, and this should be chest height minus row minus y minus 1 times height. So that's going to give us the row in pixels. Okay, then we get the color of the square by using color row and column. That makes sense. And then we have to fill rect, and here we have to use row pixels, column pixels, right? There's I mean, that was right. So X seems more like column, honestly. But why is it like that? Is it stupid? What? So row goes until height. Yeah, it's fine, but why is it looking like that? So here it's gonna iterate all the rows, all the width, all the columns. So let's imagine where 07 is going to be. All right, so we'll probably have row is 0, column is 7 at some point, right? So we'll get column in pixels is going to be 7 times something, and the row is going to be the row in pixels is going to be also 7 times height. So 7 7 basically. Okay, so as per usual, parentheses matter actually, because I guess indexing has a higher precedence order than the reference, so probably it meant something different here when I was doing this. But yeah, it was working even before, so it was just parentheses missing. Anyway, happens. Okay, so let's do some other pieces. For instance, board. Maybe I want a helper function, static void chess set square set, and then I give it chessboard d pointer board row column piece, and then I can do something like board at row column is equal to piece, and now I can say chess square set board 0 0 rook light, right? Maybe that's a bit better. Then at 0 1 we have knight knight 0 6 0 2 I think it's a bishop 0 5 should also be a bishop. At 0 3 I think it's the queen, and 0 4 should be a king. So if we check this stuff, we should see all the pieces on the bottom. I think it's called the rank instead of row, but yeah, whatever. So for the same stuff, but on 7, we should replace everything with all the light, I think it's S, light with dark, and we should see also the dark pieces now. Nice. And for the final touch, let's add the pawns. So I should do chess square set board right on the first like on rank 1 and on rank 6 we should do dark. So this should generate the, it's missing one. I guess here I need to do 8. So this should be reset board, right? If I call reset board, it should give us this thing. And at this point, we should be able to click on one piece and see the possible moves, right? And then actually do the move. So let's see if we can do that. Okay, so we have a reset board, and I guess we should be able to see clicks now on the canvas. So maybe we can implement that. Maybe we'll just do something like initial commit. I don't know if I have the initial commit, but whatever. So, or maybe, I don't know, feature place pieces on board. It's the first step. I guess inside of index.ts, or actually in wasm.h, we need this kind of function that lets us click, right? And we did that actually in Connect 4. We had this canvas clicked x, so the x coordinate where we clicked, but I would like to have like clicked x and y. Maybe that's a better one. Or maybe we'll have clicked x and clicked y separate. Like, we'll see. So if we go to our index.ts, we might be able to add just canvas clicked x and clicked y, and we need this global variable x coordinate to be able to do that. So if we check that, we have this kind of global variable, right? And inside of our JavaScript code, we'll add an event listener for click, and we have x coordinate, y coordinate, and when we click on the canvas, we get the x and y coordinates. So event.client y minus rect top, I would say, right? Because I think it starts from the top with the clicks. We can actually console log x coordinate y coordinate just to check. And in here we'll have clicked x and maybe clicked y. Although it would be cool to have both of them at the same time, but I'll have to check how we can do that. How we should be able to return. So here it's it starts from the top, right? So this should be like 0 0. So we can convert these things to chess coordinates. Perfect. So we get x and y. Now, yeah, it would be quite interesting to combine them. Like, I can combine them in the higher part of a number, of an integer, and in the lower part of an integer, but that's kind of like the other way to do it would be to use memory and write that into memory. I think we can do that just to explain how it could work, right? So clicked pixels, maybe clicked px, and here we are going to have the structure pointer. So it's gonna be maybe a position, and it's gonna be a number, right? And it returns void. So how this thing is going to work, we need the memory buffer, right? And we need to we need to write x coordinate and y coordinate into that, and then reset x. So x coordinate is equal to -1, y coordinate is equal to -1, but before that we need to write it into memory. So how can we do that? uint8 array. So what can I do here? Maybe JavaScript number to uint array. How to encode integer to uint array. I think this is what I need. So it converted the number to big int. Position star plus 1, position and length. Interesting. 4-byte answer. This is what I would like, maybe. So int to array. Nice. This is what I needed, int to array. It's a pretty nice one. So if I just copy paste it somewhere, let's say here, you can see what it does. This int to array function, it takes a number. Let me just number, and obviously it returns uint8 array, right? So it constructs an uint8 array. First element is going to be the first byte of the number, second element second byte, third byte, and fourth byte. I think that looks fine. And how can I use, so maybe I can say something like const x is int to array, x coordinate const y is int to array, and I would like to set the uint array at position to these values. So how can I write that? Maybe the easiest way to do it is with for loops, like for let I is equal to 0, I should be less than 4 I plus plus, memory at position plus I should be x at I, right? And I guess I can put it in the same place. Memory at position plus I plus 4 should be y at I. I think that should actually do it. Right, JS canvas clicked pixel. And what we can do inside of our WASM thingy is copy paste this thing, is going to be an extern void function, and this thing will have, we need a structure, so maybe type def struct point t, and it's going to need two numbers, x and y, and we'll have here, oops, point t pointer, point whatnot. Okay, so now we should be able to go into the chess WASM C code and hopefully do some stuff with this function, but for now let's see if it compiles. Okay, what can we do with this thing? Let's say point t point is equal to 0, then we call to this function, and if point x is not -1 or point y is not -1, then maybe board at 4 I don't know is equal to 1. Let's just make a random thing appear. So if I click anywhere on the board, it should spawn a pawn there. Okay, nice. Perfect. But now I would like to have some kind of function that converts from a point to a row and column. So we can have a static void chess, or like px to square, and it's going to be a point t point, and I don't know if I want to return a row and column like this, or if I want to have a point t structure for row column, but we'll see. All right, I mean, it's kind of maybe because, well, honestly, I already have this square t, so maybe we can just use square t, which I mean is the same thing, but so if point dot x is equal to -1 or point y is equal to -1, then maybe I just do square dot column, square dot row is -1, and we just return. Okay, and instead of point we have to use arrow. Fair enough. Otherwise I'm gonna just do square column, and we divide this thing by chess width. Wait, not really. we need to divide by JS width. We need to divide by the cell width and height actually. Okay, perfect. So we need to say here cell width. Nice. Square row. We divide by cell height. Nice. So px2 square. So I'm just gonna do here px2 square. Why did I make this one pointer though? It doesn't need to be a pointer. Okay, so here I need square t. Perfect. And we need to do something like if square dot row is not -1 and square dot column is not -1, then let's just just set okay. So we need to pass in reference to board. Again, maybe here I want to give it the actual square, but we'll see. Oh, oops, square column on right. So now this should, oops, index out of bounds. Really interesting. Well, I know it was the other way around, but so this was the top. So maybe I need to do something else as well in here. Like the Y position, maybe I need to do canvas height minus point Y, but that's, not important or not that important, I think. Yeah. It sucks that we don't have logging or that good of a logging. Let's think about it. So pixel to square. Yeah, I don't know if this thing is good though. The int to array. I mean, I see it's little endian, which is good, right? That's good. But doesn't really work, right? Doesn't really work. I mean, obviously the row is gonna be greater than 8, right? That's the problem. Or column is gonna be greater than 8. So that's kind of annoying. Because yeah, I mean, I set the memory to the right position. That's kind of fine. So what could be the issue here? I mean, pixel to square, that's fine. So like, I don't know, we can just pretend that, I don't know, point dot x is equals 100, point dot y is equal to 600 or something. And if I just run this thing and I refresh, I guess this is 100 by 600. 6, yeah. So you can pretend I clicked here, so that's fine. Alright, so it means that this function just canvas clicked pixel is not right. Let's see what the memory is. Console.log memory slice at position and position plus 8. Why can't I see? Oh, well, yeah, I guess it's -1, right? But if I click on it, it's gonna be 0058. I don't even know where I clicked, honestly. Okay, let's try again. So if I click on this one at the top here, it should be like, or I guess at the bottom, right? It should be close to 0. But this one is not. 0003. Somehow to me this doesn't look like Little Endian. Something's annoying here. It's 003. Let's also print, so console.log x coordinate, because I'm curious to see, oh, I'm curious to see the actual coordinates and their representation. So it's 00011, which I guess makes sense. But if I think about it, shouldn't it be 1100 if it's Little Endian? Wait, I think the order is not right in this thing. Wait, now it's Little Endian, right? Is the first byte first? Maybe that's the problem. Oh yeah, that was the problem. So it wasn't Little Endian. I mean, I knew it had to be Little Endian, but I guess I didn't see that it wasn't here, Little Endian. Okay. And you know, the reason why we have to do this crap is because I mean, if you watched maybe some of the videos from the past month or so, we looked into memory layout in C, and you might remember, let's go into WASM.h. You might remember that a structure that looks like this, it takes up 8 bytes because it's two integers, and they are right next to each other. So when we want to send some stuff from JavaScript, we cannot reuse objects because the objects from JavaScript are not represented in memory the same as C structures, right? And the C structures are basically just an array of bytes, and you can just fill them in. So here we just placed 4 bytes for the first field and then the next 4 bytes for the second field. So we just serialized some data into memory directly, and because we already knew, we assumed that we knew that that's how C structures look like because you watch the videos, then yeah, it was pretty straightforward what we need to do. But if you didn't know that, then it could be quite confusing, right? So this right here is the memory, like the RAM memory, and we wanted to write at this position, we wanted to write two numbers because that's how this structure will look like in memory. It's two numbers right next to each other, and it just happens that in C we need to use little endian for our data. Anyway, so that was that explanation. Let me just format the index file just to make it look a bit prettier. Okay, nice. So yeah, that was the idea there. Okay, so next thing that I would like to do is to actually select a piece. That would be quite nice to have a function that you select a piece. So we have pixel to square, that's a good thing to have. And then if we have an actual position on the board, we should do some stuff, right? So we should be able to do some stuff. But set square is not really what we need to do. So I guess what I need is a variable for the selected piece. It might need to be global. So it's like, okay, you selected this piece, and we can even highlight the square that has been selected. Or maybe even just having something like hover instead of clicked, right? And hover would be just where your cursor is, and then you would have something like clicked as an event, and then you did a click, because maybe hover is more interesting to have. Let's change clicked to hover. So where you hover, right? And then x coordinate and y coordinate are for hover. So here I guess there is an event called hover. Canvas hover event. Maybe we can have some mouse events. Mouse down, double click. Do we have hover? Oh my god, that's fucking annoying. The sounds. I mean, it has click, but mouse over event. Do we have mouse over? We looks like we do. Does it work with client X and client Y? Also looks like it does. Interesting. Let's also add event listener click event and here we'll have clicked equals false and we'll just make it true. Okay, and then we'll have a function js canvas clicked and it just returns a number. What the fuck am I doing? Just returns a number, and I'll do something like return clicked one else, but maybe if clicked we return one and click becomes false, otherwise return 0. And in WASM h extern int js canvas clicked. So this is like hover pixel where we have our mouse, and in here maybe we just say that and js canvas clicked. Right, so if we click and we have the mouse over a certain position, so it doesn't work. What? It doesn't work as I expected. What other options we have here? So mouse move. Maybe mouse move is the I mean, honestly, even if you click, you should be able to do something like this, but it's kind of annoying. So how can I have an event where it's like hovering on the switching up all the pieces with pawns? Yeah, I don't know. Okay, WASM H. Maybe I want to JS draw outline or something. So it's gonna be XY probably width and height. So I want to outline the selected rectangle. Maybe that's something cool to see. Right. So this thing converts into a square. So if I have this thing, I want to call to JS canvas, no, JS draw outline, and in here I want to just outline the square. So it's gonna be something like square.column cell width. We need all of that. Maybe I need to compute it every time. Kind of annoying, but it is what it is. So we get the column, we get square row, and then we have here column pixel. Wait. Yeah, column. Width and height should be width and height. And then we have the color. What color should I use for highlight? Let's use 0x RGB. Let's use blue for outline. So if we go to index.ts and we copy paste this thing, draw outline, here I think I need something like stroke style and then stroke rect. Not sure, but we'll see. And doesn't work. Stroke rectangle. JavaScript draw rect. So it's called begin path, rect, and stroke. Stroke rect. The fuck does stroke rect do? Stroke rect. Let's see an example. Whoa, it should create a rectangle. What the fuck? Oh, you know what happens? Now what happens is print chessboard also does JS clear canvas. Let's not do clear canvas. Let's do clear canvas manually at the beginning of our stuff. Oops, here. But the other problem now is I think it's overwritten. So let's go here and let's draw the outline after we draw the board. Let's see how big it is. So we have some kind of outline, but it's only when the cursor is moving, so it's kind of ugly. Yeah. Okay, so I have another idea then. So let's go into index.ts, and when we have this hover pixel, Let's not reset the x coordinates because it's just for hovering. Oh, the fuck? Why did it go there? Oh no. Oh no. Oh, it's because I'm doing this here. I should do it here. See, but what's cool now is that we have some kind of highlighting over the squares when you hover over them, which is pretty nice. So obviously the next step would be to just be able to move a piece. So how can we do that in an easier way? Maybe I really need like square T selected, so which piece you selected. And then somehow being able to move the piece. How can we do something like that? I guess square T selected, and that's also like in theme with select. Maybe I'll call it select. Select. Maybe we want another function, static int square valid square T square, and it's something like return square row is not -1 and square dot column is not -1. So now we can just call square valid on this square instead. Square valid square. I mean, you know, that's not needed, but you get the point. So square valid. So let's go here, select. So if we click and the square is valid, then we need to do something like if board dot square dot row square dot column is not empty, we set the select to square. Right, and I would say initially select should be -1. Right, and here maybe I need to say something like not square valid of select. So if select is not selected and it's empty, then we do that. And then if square valid select, then we have to move here. Which, I mean, apply move would be the idea. Just apply move, and we go from select to square. That's the target. And we need to implement this chess apply move, chess apply move. So all that this does is char piece is equal to board, select row, select column, and then set piece or chess square set. Okay, and we give it target row, target column, and the piece. Let's run again. So now if I select the piece, it it moves, but it's still there. So if I select the queen, oops, and I forgot to unselect it. So afterwards we have to say select row is -1, select call is -1, and maybe where the piece was we set empty, so we reset the position. So now if you can, oh, what the fuck, select row and column. Why doesn't it work? It deletes everything. Okay, let's think about it. So if the square is valid where I clicked, and we have a click event, right? If I don't have a piece selected, and that's by checking if select is -1 -1, then we select the square. If the square is valid, so it's like otherwise, let me just put an else, maybe that matters. So if we have a piece selected, we apply the move. That's that. Let's see. So I select this thing, I move it. It's fucking annoying, what the fuck. So square is valid, that's true. And I clicked. Then I just set this else if, so it's like the else statement, else case. We apply move, and apply move takes the piece from the selected position, it sets empty at the selected coordinates, and then it sets this, and then select, shit, select cannot be modified. I guess we need to modify select here. So I move that, and I mean, you could just play like this and pretend that it's like I don't know, working, but it's kind of annoying because I don't see really well, honestly. Then you can like obviously you can make cheats moves, like it's not going to care that it's oh shit, what? I think I took the queen with the pawn. Like, you could do stuff like this. No, it's not going to stop you. So that would be the next step, right? Being able to make the pieces, work as they should. Because, wait, why cannot I? Okay, yeah, like making the pieces, respect the rules and stuff like that. That would be nice. I think it's a pretty good start so far. Like, we have the board. I would still change the colors. It's still kind of ugly. So maybe let's have here something like square dark, and it should be something like 0x. I don't know, 18 RGB. Let's make it green dark or something. I don't know if that's define square light. And I think for light it works with FF. Square light, square dark. I think it works with white. Ew. 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 That was ugly as fuck. Oh, I think this one looks decent. Maybe a bit. I don't know. I think it looks decent. But yeah. And yeah, like the next step would be to make the pieces actually, work as they're intended. Because right now you can just randomly move, right? And yeah, so that would be the next goal for this project. So yeah, hopefully this was interesting. I mean, we saw some things about C, like the main important one, which, it was just because I wanted to implement it that way, just to showcase it, was how to use structures with WASM. I think that's pretty interesting if you get yourself into that. It's good to know that, C layout is basically an array. So yeah, the C memory layout is basically an array. So if you haven't seen that video, you can check that one. It's pretty useful for C development. But yeah, other than that, we'll see in the next one. So see you.